AgriRobo is an automated seeding and monitoring solution for small-scale farmers. We have designed a friendly graphical user interface allowing the farmers to specify the farm dimensions as well as the mission type, whether it is a seeding mission or a monitoring mission. From the monitoring tab, all the needed information will be provided to the user. In order to enhance the robot path navigation, we have implemented a path correction algorithm using AgriRobo markers, which will correct the angle and the position of the robot. By doing the right camera calibration, the algorithm will be able to extract that information and correct the robot path.
To control the irrigation system, we must determine the water content in the soil. For that, we used a soil moisture sensor. Many experiments were conducted to calibrate and validate the sensor. The robot will navigate through the farm and test the surrounding area of each plant. Depending on the soil moisture percent, the system will control the irrigation system. Another feature in the robot is measuring the humidity and temperature in the farm. The robot measures these climate conditions using a humidity and temperature sensor. The robot will then send these data to the graphical user interface.
First, we built the mechanical design where the robot dimension was 35 by 35 centimeter and it has 4 wheels and 3 actuators. Then we built the design by the aluminum extrusion. For path planning, we will divide the farm to different number of row and different number of seeds. Then we will build an equation to find the exact location for each row and seed. Then by this equation we will calculate the distance and orientation. For robot movement we will use motor with motor encoder. Then for the direct movement we will convert the distance to number of count. Then we will use the encoder to control the movement. For the turn movement we will use the IMU device to control both angle and speed for the robot.
A test arena has been designed to experiment the robot in a simulated farm. The simulated farm has a width of 250 cm and a length of 160 cm. Given the farm dimensions, the system has calculated the optimum number of seeds and rows using the graphical user interface. The farm contains 3 rows and 2 seeds for each row. An AgriRobo marker is fixed right above the second seed of row 2, and when the robot reaches row 2, the camera will detect the AgriRobo marker. Therefore, the robot will correct his location based on the location of the marker. The AgriRobo marker is used in both the seeding and monitoring missions to decrease and eliminate movement errors. The controlling of the irrigation system is demonstrated using an irrigation system box.
Use AgriRobo using the graphical interface, enter the farm dimensions, then calculate the possible number of rows and seeds, and then specify the starting row and ending row, then start the mission. In this case, a seeding mission was started. The data will be sent through the Wi-Fi to the Raspberry Pi, then to the Arduino through serial communication. Once the data received, the robot will start to navigate through the farm. Reaching row number 2, with the first seed of the row, the robot will correct its position and angle using AgriRobo markers as explained before. The same for measuring mission. The farm dimensions will be entered and sent to the Arduino. Once the data received, the robot will start to navigate through the farm. At the end of the measuring mission, the robot will determine whether to turn on the irrigation system or not.